Our next section is about sampling and surveys. So oftentimes when you want to find out information about a group of people, you will have them take a survey. However, it's impossible most of the time to get every single person. For example, if you want to find out about everybody in the US, you can't reasonably give them like every single person in the US a survey. So oftentimes you will do what's called taking a sample. So first of all, I'll give you two words. The first word is the population. So the population is the entire group that you want information about. And you often see polls, especially during election years. You see polls that are taken. They don't actually ask every single American voter about it because it would be close to impossible to get all of them. In that case, however, their population is all the American voters. But actually, when they ask the questions, they actually only get a sample. So the sample is the smaller part of the population that they actually get information from. And sometimes I draw like a little picture. So our population is the entire group. Within our population, we have a smaller sample. Okay, so let's do the first example. In these, I'm going to identify the population and the sample. And usually you're going to have the sample, they're going to actually give you a sample size. So in this case, they tell you the student government at a high school surveys 100 students at the school to get their opinion about a change to the bell schedule. In this case, the sample is the 100 students. They don't explicitly state what the entire population is. However, in this case, the population we are going to assume is going to be all students at the high school. Okay, so for part B, they tell us the quality control manager at a bottling company selects a sample of 10 cans from the production line every hour to see whether the volume of the soda is within acceptable limits. This is actually often done with factories and other manufacturing things like this. So in this case, the population is going to be all possible cans of soda that this company produces. We're going to assume that there's a lot of them, so it wouldn't be feasible for them to test every single one. The sample is the 10 cans per hour that they actually test. And one other thing I'm going to mention is that you want the sample to be a good representation of the entire population. We are always looking for what we call a representative sample. That's very important. And that's going to bring me to the next group of terms for this chapter. So we always want to get fairly representative samples. And there's a few ways to do this. So I'm going to tell you right now that these 5 at the top are not always good, but they're oftentimes good. These 2 at the bottom are almost always bad ones. So just keep that in mind. Don't come away from this thinking that a convenient sample is a good thing. And I'll explain what that means in just a minute. So my first type of sample is what we call a simple random sample. This one's used so often that we just abbreviate it as SRS usually. So what we do with a simple random sample is, let's say that we want a group of 100 students, as in the first example. If you do a simple random sample, you find a sample such that it is 100% random. So you can put every single student's name in a hat and pick out 100 of them. You can use a random number generator and assign every student a number, but it is going to be completely random. So in that case, I'm just going to say completely randomized. And there's going to be a few things with that are important. The first thing being that every single person or every single item that you're sampling has the same probability of being chosen. So they have equal chance of being chosen for the sample. So the second type of sample, oftentimes you think that, wow, a completely random sample, that sounds great. Some of them are even better though, like a stratified random sample, for example, might actually in many cases be better. So a stratified random sample is going to occur when you put the population into groups, which we call strata, and then you take an SRS from each one. So we'll say we'll put the population into groups. So this, for example, would be if that example that had the high school in it, they were looking for 100 people. A stratified random sample would occur if they took each grade, 9 through 12, and they selected a random sample of 25 students from each grade. That would give us a stratified random sample. It actually might be even better than a simple random sample because you would have equal representation of all grades. A cluster sample is going to be where you divide the population into smaller groups and the difference between each of these types of groups is that with a cluster sample, we want groups to be, you can have many different types of people or things. And in a stratified random sample, you want similar people within each group or objects. Okay, so with the cluster, we're dividing the population into groups where you have a good representation of the entire population, and then you are going to sample everybody in each group. This one actually is a little bit easier than the previous two because if you just have a big chunk of people and you ask all of them a question, you're not going to have to go around assigning numbers to people and trying to get it to be completely randomized. So cluster is generally a little bit easier. So the systematic sample is, that's our next type. And the systematic sample is going to be a random sample where you choose a random starting point, and then you ask either like every 10th person, every other person, every third person. I'm just going to write you ask every nth person. Just know that it can be like 10th, it can be the third person even. But this is actually a good way to get a good sample. For example, if you were doing a sample of students that eat in the cafeteria, and you were to ask every like fourth person in line, that would actually give you a really good representation because it would split up friend groups, and so you would get a good mix of people. So a multi-stage sample, this one, I don't think it's actually even in your book. It might be listed in there. It usually doesn't appear on the AP test, but just in case you hear this at some point in the future, a multi-stage sample is going to use more than one of the above. And by the above, I actually mean the second, third, and fourth ones. Not the SRS. Sometimes people think stratified random is a multi-stage because it uses an SRS, but not necessarily. So it's going to use more than one of the above. For example, you take a stratified random sample, then within your stratified random sample, you ask every third person or something like that, and you do stratified and a systematic. You don't often see them, but just in case you do, that's what that is. I would say out of these, the first three, simple random sample, stratified random sample, and cluster sample, are the ones that are most likely to appear on the AP test or on my test. So just make sure that you know those three. The next two things are our bad types of samples. The first one is a voluntary response sample. Actually, if you go on any news website where they ask you to take a poll or something, that's a voluntary response sample. So that's when you have a survey that asks for volunteers. So, or it can be just any other type of sample. Like if you're doing an experiment, you ask for volunteers. So this generally, especially with a survey, it's usually not going to be that great. Especially, for example, if it's a poll on a website, because generally the only people that actually respond are people that have very strong opinions. It's usually going to be only the people that care. The other type of bad sampling is a convenience sample. So if I were asked to ask you to do a survey of all the opinions of students at the school, and you just asked all your friends, that would not give you a very good sample. So a convenience sample is going to be where you ask the people that are easiest to get to, or the people that are closest to you. So you choose people, or you choose individuals. Who are easy to reach. Who are easiest to reach, I should say. So this one won't give you a very good representation. So the next question, you don't have to write anything down, but I just kind of want you to think about how you would do this, how you would conduct a sample of Lorena students, if you wanted 50 students each. So if you want, you can either pause and think about it, or I can just give you examples of each of them. So in order to get an SRS of Lorena students, of 50 students, all you would have to do would be to take the entire list of students. You can either take everyone's name and cut it out, pull it out of a hat, or even easier would be to assign everybody a number. Then you can use a random number generator or random number table, which we'll do in just a minute, and you can use that to choose a few people at random. For a stratified random sample, best way to do that would be to get maybe eight or so people from each grade and choose them at random. So choose the 8 at random from each grade. A good example of a cluster would be if you have family groups or something where you have all sorts of grades within each group, just choosing enough of those groups and asking every single person and getting a mix of all grades. Systematic would be, the best way to do that again would be to take a list of all the people at the school, but then maybe ask every 10th person on the list. Multi-stage would involve just using 2 or more of these. For example, if you were to do a stratified random sample, meaning that you took a sample of maybe 20 from each grade, and then after that you asked every other person on the list of 20 that you had, that would be systematic and stratified, so that would be an example of multi-stage. Voluntary response would be if you put up posters around the school and said, hey, do this survey. And convenience would, again, I think I mentioned it, asking all your friends would be a good way to get a convenient sample. Not a good sample, though. Okay, so this next example is going to actually ask us to use a list of random numbers to select a simple random sample of 5 stores. I don't know why. I guess a simple random sample of size 5. So what I'm going to do is I'm going to go through this list, and you'll notice that everything, for example, like All-American Burger, I didn't write that as 2, I put it as O2. The reason that I'm doing that is so that I can give every single store a 2-digit number. When you're doing this, it's important to have the same number of digits. What I'm going to do is I'm going to go through the table. I'm going to find any number that I'm going to start from the left. Any number that corresponds to a store, I'm going to choose. Any number that doesn't correspond to a store, I'm going to cross out, and any repeats are also going to be crossed out. And I'll show you what I do. It'll make more sense when I do it. So the first one, I'm going to go 2 by 2. The first number I have here is 20. So I am going to choose Vitamin World. That's my first choice. The second number you'll notice, I have 35. There is no 35, so we're not going to use that. Now what I'm going to do is I'm going to actually hop over the next line, and I'm going to use the number 16 for my next one. It's important that you don't skip any numbers, otherwise it ends up being not completely random. So then 16 is the next one I get. That one is PacSun. The next one, number 25, again, that one's not listed, so I'm not going to use that. I got 16 again. I am not going to do a repeat on my sample. It's important to have different stores included. And the next one's number 8. That one's going to be Forever 21. 54, once again, I'm going to cross out. 22, going to cross out. 34 and 24 and 49 are all going to be crossed out. The next one I have is 18. That one's a good one. That one will give me Payless. And the last one I have is 11, which is going to give me Hager. So this is an example of a way that you can use random numbers to find a good sample. This is a completely randomized sample. So it's a simple random sample. So I'm actually going to ask you to skip example number 4. We're going to do it in class tomorrow. We'll do it in pairs. And I want to go over what inference is. So you do not need to memorize this definition. However, you will see this word used again and again and again. I actually think an entire unit of your book is called inference. So what inference is, all it is the process of making conclusions about a population based only on a sample. So this is a very, very, very important concept. It's pretty much what the entire class is about. That being said, you're not actually going to have to memorize this word. You might see it mentioned a bunch of times, but this is what we're pretty much doing in the class. The next 3 words you do need to know, undercoverage, non-response, and response bias. These are 3 issues that you can have when you're making a sample. Sometimes they are due to poor sampling, other times they are just due to the way that the population is. So undercoverage is going to happen when some groups in the population are left out of the sample. And I should say they are left out of the process of choosing the sample. For example, if we have an extended homeroom at school and we do a survey during that extended homeroom, and we're going to assume that nobody in your class would do this, but sometimes students will not come to school during an extended homeroom, they come afterwards. Those people that didn't come to school are going to be left out of the sample survey. So we say that there is undercoverage because the groups of students that decided to skip school because of the homeroom, their opinions are not being heard, and maybe they deserve it. So non-response is, it almost sounds similar, but usually this is going to happen when the people running a survey or choosing the sample actually do want these people in the sample, but for some reason these people refuse to participate. Or they refuse to answer questions. The last one is called response bias. This one's important. So oftentimes this comes if you're asking sensitive questions. For example, if I were to do a survey about like teen drinking or something like that, and I were to ask you face to face, not doing it anonymous, I would assume that I might get some people that don't respond the way that they truly believe. So what a response bias is going to usually occur when people do not answer truthfully. So you don't get the correct responses. And it's usually going to be untruthful responses.